we are going to look at the quadratic formula. The quadratic formula is just a tool that we use to find the roots of a quadratic equation, although it is not as fast as manually factoring the quadratic equations. You can use this for harder types of quadratic equations or harder trinomials once they have like larger coefficients and aren't so easy to factor. Sometimes they even get irrational, or sometimes they don't even have a root. That's when you find it with the quadratic formula and you can't use the normal way of factoring it. So the quadratic formula, once again I'll mention, is used for the quadratic equation or trinomials. These trinomials have a general form of ax squared plus bx plus c equals 0. And we will be substituting these coefficients to find the roots into this quadratic formula that I will show in just a second. And bear in mind that this is used to find the roots. What are the roots? The roots are numbers or integers or fractions or even rational numbers that when you substitute them into x right here, that equation that you have will equal to 0. So for the time being we will have these x's, and once we find these x's we can substitute them with the roots, and then we add them all up and they will equal to 0. That's what a root does. It makes it equal to 0. So the quadratic formula, even though this will seem quite complicated, once you get the hang of it, once you use it even more and more and you practice with it, you will easily remember it. It's just negative b plus minus the square root of b squared minus 4 times a times c over 2a. Now this looks really complicated. How about we try a simpler version, which is negative b plus minus the square root of the discriminant over 2a. Now this looks much simpler, but we have to bear in mind that d right here, the discriminant, is basically just b squared minus 4ac right here. So you can make this as a short version of the quadratic formula, but we have to bear in mind and we have to remember that the discriminant right here is b squared minus 4ac. So let's look at an example. For example, we have 2x squared plus 3x minus 2. So let's just look at this. 2x squared minus 3x plus 2. And as you can see, if we try to find the a, b, and c here, the coefficients, a right here will be 2, as it is in front of the first x term, the x squared. B right here will be 3, and c, the constant, will be negative 2. So let's just substitute this into the quadratic formula. So right here we have negative b, so b is 3 and negative b is negative 3, plus minus the square root of b squared is 3 squared, which is 9, minus 4 times a is 2 as we know, times c. C right here is the constant, which is negative 2, not only 2, but it is negative 2. And we divide all of this by 2a, 2 times a, which is 2 times a right here is 2, 2 times 2 is just 4. Now, let's just try and simplify this. Negative 3 plus minus. Now, negative 4 right here times 2 is negative 8. Times negative 2, we know that a negative times a negative will become a positive, so negative 8 times negative 2 is positive 16. We will have 9 plus 16, or 9 positive 16, over 4. And now that we have this, let's just simplify it even further. 9 plus 16, that will be 25. So the square root of 25, what is the square root of 25? Yes, that's 5. So this will result in negative 3 plus minus 5, because that is the square root of 25 over 4. Now, here we will have two roots. The first x or the second x is up to you. You can make it a plus or a minus. This is just how it goes. I prefer to do the positive first. Well, this will be negative 3 plus, not the minus first, so negative 3 plus 5 over 4. Negative 3 plus 5 is the same as 5 minus 3, which is 2. 2 over 4. This is the same thing as 1 over 2. The second x is, because we have used already the positive, now we'll use the minus. Here we have the plus, now the minus. Negative 3 minus 5 over 4. Negative 3 minus 5 is negative 8. Negative 8 over 4 is negative 2. So right here we have the first x, which when simplified is 1 over 2. The second x, which when simplified is negative 2. These are the two roots. These are the answers. So the first root will be 1/2, or vice versa. It's up to you. You can have the first root as negative 2 or 1/2, is up to you. But all we know that if we substitute 1/2 or negative 2 into the x's right here and add them all up, it'll equal them into 0. So let's try and look at another example. Let's look at, for example, x squared minus x plus 12. So right here, a, because 1 times x squared is just x squared, right here is just 1. A is 1. Negative x, this is basically negative 1 as b, because negative 1 times x is just negative x, and the constant is 12. So let's remember again the quadratic formula. Negative b plus minus the square root of b squared minus 4 times a times c over 2a. Now let's just substitute this into the quadratic formula. First of all, negative b because b right here is negative 1. So negative 1, negative times negative is positive, so it'll leave us with positive 1 plus minus the square root of b squared. Negative 1 squared is 1, because negative 1 times negative 1 is the same thing as negative times negative, which result in a positive. Minus 4 times a is 1, times c is 12, over 2a. 2 times 1 is just 2. Right here we will see, if we try to simplify this square root, negative 4 times 1 is negative 4, negative 4 times 12 is negative 48. 1 minus 48 will be negative 47. So it will result like this. 1 plus minus negative 47 over 2. Now, what will be the solution to this? Well, we know that a negative square root is not possible in the real number world. So this quadratic equation, the one up top here, x squared minus x plus 12, has 0 roots. It has 0 roots because the square root of the discriminant is negative 47. Let's just look at one more example. Let's look at x squared plus 6x plus 9, and let's substitute this into the quadratic equation. Negative b, as we remember, negative b is right here is 6, negative 6 plus minus the square root. B squared is 36 minus 4 times a is 1 times 1 times c is 9 over 2 times a a is 1, 2 times 1 is just 2. So right here we will see that the square root will equal to 36 minus 4. Minus 4 times 1 is negative 4. Negative 4 times 9 is negative 36. It will result in 36 minus 36. That will result in 0. The square root of 0 is just 0. So x, 1 and 2 will result in negative 6 plus minus 0. Whether you add or subtract something with 0, it'll just result in the same. So let's just erase this plus minus 0, because it will result in any way, shape, or form, it will result in negative 6. So negative 6, this will leave us with negative 6 over 2, and it'll leave us with negative 3. Now, the first x and the second x will be negative 3, so there's no need to say that there's the first x and the second x. We can just say that x is equal to negative 3. And this is called a repeated root. So this quadratic equation has a repeated root, and that root is negative 3. Now, for some of you who still doesn't understand what a root is, I said at the beginning that a root, when substituted into the x's, into this x squared and x, will make the equation, when added up, equal to 0. So let's try substituting this root into this equation. So negative 3, we substitute it with x. Negative 3 squared, negative 3 squared, negative 3 squared, plus 6 times negative 3, plus 9 equals 0. Let's see. Negative 3 squared is 9. 6 times negative 3 is negative 18. Plus 9. 9 plus 9 is 18. 18 minus 18 is 0. So we see that this will actually result in 0. So I hope you now understand what a root is, and I hope you understand how to use the quadratic formula and how to find the roots of the quadratic equation. So once again, the quadratic formula is minus b plus minus the square root of the discriminant. Remember, the discriminant is b squared minus 4ac over 2a. So this is the quadratic formula, and it is used to factor trinomials or quadratic equations in, well, I guess this is one of my favorite ways to factor trinomials or quadratic equations, by using the quadratic formula, because for me it looks really neat. So that's all.